Hey everyone, get ready, because today we're diving deep into the world of 18th century science.
Yeah, we're talking frog legs, sparks.
A scientific showdown for the ages.
Exactly.
You send us all this research, historical accounts,
Yeah.
all about the early research into bioelectricity, focusing on Luigi Galvani and all the controversy around his work.
Yeah, and what's so fascinating about this deep dive is that we're not just like uncovering old science, We're really trying to trace how these ideas evolved, how, even the wrong turns can be super illuminating.
So picture this. It's the late 1700s, okay? Electricity is still pretty mind-blowing stuff, right?
Oh, yeah.
Like the idea that living things could make their own electricity.
Wild.
That was basically science fiction.
It's true. But you know what? The idea of animal electricity, it wasn't totally out there. Think about it. Electric eels, torpedo fish.
Right.
They'd been stunning people, shocking scientists, really for centuries.
Yeah?
Doctors were even using them to treat paralysis.
Oh, wow.
Hoping that jolt could kind of jumpstart a patient's own system.
It's like electroshock therapy, but with seafood.
Right. Exactly.
But it wasn't just those, electric fish.
Yeah.
There was this buzz that electricity played a role in all sorts of life processes.
For sure. Some scientists, they believe that electricity was like a vital force coursing through living tissues.
Interesting.
They called it the electrical hypothesis.
Okay.
Others, they were convinced that nerves were sending electrical signals to the muscles, making them contract. The spreading hypothesis.
So we've got these intriguing theories.
Yeah.
What's the evidence like?
Well, that's where things get a little tricky. A lot of these early hypotheses were more speculation than like rock-solid proof.
Right.
Many of them focused on the effects of external electricity on living things,
Okay.
not on the possibility of an internal source.
I see. So it's like trying to figure out how a car engine works.
Yes.
But you're just watching a lightning storm.
Exactly.
It's interesting, but not that helpful.
Not really.
Okay. So the stage is set, right?
Right.
We've got this world on the cusp of understanding electricity.
Right.
And you've got scientists hungry for answers.
Yeah.
And these little hints that life itself might be electric.
Exactly.
Enter Luigi Galvani, this Italian professor of obstetrics, who, you say, was about to drop a scientific bombshell with a single frog leg.
It all started with, like, this simple observation, but super profound.
Yeah.
Galvani's dissecting a frog, pretty standard practice at the time, when he notices something really bizarre. As he touches the frog's exposed leg with a metal tool, the leg twitches.
What?
Like it's imbued with a life of its own.
Wait, so he wasn't even, purposely zapping it with electricity or anything? Incredible. Talk about a happy accident.
Total serendipity.
Wow.
It wasn't a planned experiment, just a chance observation.
Wow. So how did this frog leg experiment change what we knew about electricity?
So this is where Galvani's work takes a turn.
Okay.
He wasn't applying external electricity like others had done.
Right.
He became convinced he was tapping into the frog's own internal electricity.
Wow. What he called animal electricity.
Exactly.
So he's saying the spark of life, that's not a metaphor.
Yep.
It's literally electric.
That's what he thought.
To support that, he did a bunch of experiments, right?
Oh, yeah, meticulous experiments.
Yeah.
He tried different metals, kept detailed records.
Right.
He even went to great lengths to rule out other causes like friction or static in the air.
So like a scientific Sherlock Holmes, eliminating every other suspect.
Exactly. He was determined to prove that this animal electricity was real.
And what did everyone else think?
Well, you can imagine it was a mix of excitement and a healthy dose of skepticism.
Right.
Some people were ready to embrace this whole new understanding of life.
Yeah.
Others, not so much.
And that's where Alessandro Volta enters the picture.
Exactly.
He wasn't sold on this whole animal electricity idea.
Not quite. Initially, he was intrigued, but as a physicist, he brought a different perspective.
Right, right.
Volta was sure that the electricity wasn't coming from the frog itself,
Okay.
but from the contact between the two different metals in Galvani's arc.
Interesting.
He thought the frog was just a conductor,
Okay.
kind of like a Leyden jar.
A Leyden jar, what is that?
Think of it like an early battery, a way to store static electricity.
Okay.
You could charge it up, then discharge it with a snap.
Interesting.
Volta thought the frog leg was acting like that Leyden jar,
I see.
holding the charge created by the metals, not generating it itself.
So Volta is saying, hold on, it's the metals that are important here, not the frog. And this little disagreement sparked a scientific rivalry for the ages.
Oh, absolutely.
So it's like Team ɡælťvɑːni over here, right, with their animal electricity, this mysterious life force inside us.
Yeah.
And then there's Team Volta saying, nope, it's just the metals.
Right. Exactly.
But they're both out there doing experiments trying to prove their point.
And that rivalry, it really pushed the boundaries of what they knew about electricity back then.
Totally. And it led to some huge discoveries.
Huge. Yeah. I mean, Volta, in trying to disprove animal electricity, he actually stumbled onto something groundbreaking.
Okay. Tell me more about this groundbreaking discovery.
So Volta, through his experiments, he found that by arranging different metals, he liked silver and zinc.
Okay.
And then separating them with cardboard soaked in salt water, he could create this continuous flow of electricity.
Wow. So he basically made the first battery.
He did. That's exactly what he did.
That changes everything.
Oh, absolutely. Volta's electric pile, as it was called.
Okay.
It was a sensation.
Yeah.
Finally, they had a source of electricity that was reliable, controllable, no more relying on electric eels.
Wow, it's like he invented the smartphone of the 18th century.
Right, exactly.
Okay, so with this new invention, did everyone just agree with Volta and forget about ɡælťvɑːni?
It wasn't quite that simple.
Really?
I mean, Volta's pile, it definitely stole the show.
Sure.
But it didn't completely end the debate.
So even with this new electricity source, this animal electricity question was still up in the air.
Oh, yeah, totally. You know, the scientific community, more divided than a plate of frog legs at a fancy Italian restaurant.
Okay, I like that.
You had some scientists. They were all in on Volta's theory.
Okay.
Animal electricity. That was a myth to them.
Right.
But then others, they were still holding on to ɡælťvɑːni's ideas, pointing to those careful experiments he did, arguing there's got to be more to this spark of life than just, you know, metals touching.
So it's like Team Edward versus Team Jacob, but with more fraud dissections.
You got it.
But what's interesting is it sounds like a lot of scientists were somewhere in between.
Oh, absolutely. Yeah. They were trying to find a way to make ɡælťvɑːni's observations work with Volta's findings, searching for a theory that could explain everything.
And the papers you gave me, they show just how intense this debate got. There were these heated arguments in scientific journals.
For sure. Each side picking apart the other's experiments. Their interpretations.
Classic.
But, you know, it's a great example of how science moves forward.
Yeah.
Through debate, through rigorously testing ideas.
Right. And out of all this back and forth, a fundamental question emerges. What exactly is animal electricity? Right. Is it the same stuff as lightning?
Exactly.
Or something else entirely?
Something unique to living things.
Yeah.
It was a huge question.
And if it was different, how did it work?
Right. What was this galvanic fluid that ɡælťvɑːni kept talking about?
Galvanic fluid always sounds like something out of, like, a Gothic novel.
I know, right?
Like this mystical essence that gives life.
You can think of it as ɡælťvɑːni's attempt to explain how animal electricity worked. He imagined it flowing through nerves and muscles.
Right.
Like a hidden network of electrical currents.
But if it was real, shouldn't they have been able to measure it somehow?
Right, that was the big question.
Prove it was more than just those twitching legs.
Exactly. But, you know, back then, the tools for studying electricity were still super basic.
Right.
They didn't have the instruments we have today.
Yeah.
To isolate and really understand those subtle currents in living tissue.
So they're working on these huge questions about life and electricity with really limited tools.
It's true.
It's amazing they discovered anything at all.
It really is. And, you know, this debate, it wasn't just about frog legs or even electricity.
Right.
It was about the very nature of life.
What made something alive?
Exactly. We're living things, just complex machines.
Yeah.
Driven by physical and chemical processes?
Right.
Or was there something more, some vital force that made us tick?
So we've got these philosophical questions, right? These heated scientific debates.
Right.
And people are fascinated by electricity.
Totally.
What's amazing is that even after Volta's battery, the question of the nervous system and animal electricity, it never went away.
That's right. The nervous system.
Yeah.
Still a total black box.
Right.
Nobody knew how it worked.
Yeah.
But there was this growing suspicion that maybe, just maybe, animal electricity was somehow involved.
So you've got this animal electricity maybe running through our bodies.
Right.
And this mysterious nervous system controlling everything.
Yeah.
Did anyone even try to connect those two?
Oh, they did. It was almost impossible not to.
Okay.
I mean, for centuries, scientists had been trying to crack the code of the nervous system, figure out how it worked.
Right.
What was this nervous fluid made of?
Right.
How did it control everything, from our senses to our movements?
It's like trying to figure out the internet before anyone knew about electricity or wires or code.
It's a great analogy.
It's just this invisible force coordinating everything.
Back then, they imagined this nervous fluid moving through the body, carrying messages to and from the brain.
Like little telegrams?
Some thought it was mechanical, like pipes with valves and pumps.
Okay.
Others pictured it more chemically, like a chain reaction through the nerves.
And then Galvani comes along with his animal electricity.
Right.
Did they think maybe this galvanic fluid was the nervous fluid?
That question, it sent shockwaves through the scientific community.
I bet.
Could this be the answer they were looking for?
Right.
Could animal electricity be the key to understanding the nervous system?
That's a twist.
It was huge.
So how did they even test that idea?
Well, they couldn't exactly hook a frog leg up to a brain.
Right.
But they came up with some pretty ingenious experiments.
Like what?
One of the big arguments against galvanic fluid and nervous fluid being the same thing involved cutting a nerve.
Okay, so we're back to dissecting frogs.
Pretty much.
What happened?
They found that cutting a nerve, it stopped voluntary muscle movement.
Makes sense.
But here's the thing.
Yeah.
It didn't always stop the muscle from contracting when they stimulated it directly.
Really?
Like with Galvani's bimetallic arc.
So even with the nerve connection cut, the muscle still twitched.
Exactly.
Huh, that complicates things.
It suggested that maybe nerves had a more complex way of transmitting signals.
Okay, so it's not just like a simple flow of galvanic fluid.
Right.
Back to the drawing board.
Right, but the sources you gave me, they mentioned these other experiments with ligatures.
Ligatures, what are those?
Basically, imagine tying a string tightly around a nerve.
Okay.
The idea was to see if interrupting the flow within the nerve, whether it was galvanic fluid, nervous fluid, or something else entirely.
Okay.
See if that affected both voluntary movement and those contractions from the bimetallic arc.
So it's like turning off a water valve.
Yes.
See what still works in the house.
Exactly. And just like trying to fix your plumbing, the results were all over the place.
How so?
Sometimes the ligature blocked both types of movement.
Okay.
Sometimes it did nothing.
Really?
It seemed to depend on where they put the ligature, what animal they were using.
Oh, wow.
Maybe even what they had for breakfast that day.
So much for controlled conditions.
Right.
But what about the heart?
The heart.
That's the most famous involuntary muscle.
It's true.
Surely they tested that, too.
They did. The heart. It was a puzzle.
Yeah, what way?
Well, if galvanic fluid was the same as nervous fluid, and it was responsible for all muscle contractions, then stimulating a heart with the bimetallic arc, it should make it twitch, just like that frog leg, right?
Makes sense to me.
What?
It's where things get messy again.
Some scientists said they could make the heart twitch with the metals.
Oh.
Others, they had no luck.
Really?
It turned into this whole debate.
A scientific shouting match.
Basically, accusations of bad techniques, misinterpreted results.
So what was the deal?
Well, a few things.
Okay.
First off, the heart, it's a tricky organ to work with.
I can imagine.
Were they putting the metals on the heart muscle itself?
Okay.
Or on the nerves that control it?
Right. Big difference.
Plus, the heart has its own rhythm, right?
Yeah.
So it's hard to tell if a little twitch was from the metals or just the heart doing its thing.
Right.
It's like that saying, if your only tool is a hammer, everything looks like a nail.
Totally.
They were trying to apply this animal electricity idea to everything.
Yeah.
But it didn't always fit.
So, in the end, was galvanic fluid the answer to the nervous system mystery?
Well, like a good mystery novel.
Yeah.
This one didn't have a neat ending.
Right.
At least not in Galvani's time.
Right.
He sparked this idea that electricity might be the language of the nervous system.
Right.
But the tools, the knowledge, it just wasn't there yet to prove it.
So he was kind of right and wrong at the same time.
Exactly. He was right about electricity being crucial for living things.
Okay.
His observations, his idea of animal electricity.
Yeah.
They opened up this whole new field of science.
That's incredible.
But he was wrong about galvanic fluid explaining everything about how our nerves and muscles talk to each other.
Right, right.
It was more complicated than that.
It always is.
And, that's kind of the beauty of science.
How so?
It's a journey, not a destination.
I like that. Sometimes asking the right question is just as important as finding the answer.
And sometimes those questions lead to even more questions.
Absolutely.
Reminds me of that saying, The more you learn, the more you realize you don't know.
Exactly. And in the case of animal electricity, even if those early theories seem a little strange now, they got people thinking, experimenting, and that eventually led to what we know today about neuroscience, cardiology.
Exactly.
We're talking pacemakers, even things like brain-computer interfaces.
All those things, they have roots in these early explorations of animal electricity.
Wow, it's incredible to think about how far we've come.
It really is.
From twitching frog legs to understanding the electrical signals in our brains.
And it all started with someone asking, what if?
That's what I love about these deep dives.
Me too.
We get to trace these journeys of discovery.
See how even the wrong turns can lead to amazing breakthroughs.
And Galvani's story. It's the perfect example of that.
It really is.
It's not just about frog legs.
Nope.
It's about the power of curiosity.
Absolutely.
The understanding that even in science, the journey is just as important as the destination.
Couldn't have said it better myself.